In this lesson, we'll take a beginner's approach to probability. As we progress through the module, we'll build on today's lesson by examining additional concepts and more advanced strategies. So to begin, probability is a quantity that measures the likelihood that some event will occur. So when we speak about the probability of an event, we are trying to assign a number to the likelihood that the event will occur. The probability of any event will range from 0 to 1 inclusive. The greater the probability, the more likely the event will occur. So if the probability is 0, we know that the event will not occur. Conversely, if the probability of an event is 1, then that event will most definitely occur. So for example, let's say that we have a box that contains 3 red balls. If one ball is selected at random from the box, we can examine various probabilities. For example, the probability that the selected ball is green is equal to 0, since it would be impossible to draw a green ball from this box. Conversely, the probability that the selected ball is red is equal to 1, since we are certain that the selected ball would be red. When dealing with scenarios with countable outcomes, we can define the probability of an event as follows. This says that if we have a scenario or experiment where each outcome is equally likely to occur, then the probability that some event will occur is equal to the total number of outcomes where the event occurs divided by the total number of possible outcomes. Let's look at an example. Let's say we have a box containing 6 red balls and 2 green balls, and we randomly select one ball from the box. What is the probability that the selected ball is green? To answer this, we'll apply the probability formula. Now, when we apply this formula, it's a good practice to calculate the denominator first. Doing so will often help us gain some insight into the question. So we'll begin by determining the total number of possible outcomes. Since there are 8 balls in total, there are 8 equally likely outcomes when a ball is randomly selected. Now we'll move up to the numerator. Here we want to determine the number of outcomes where selecting a green ball occurs. Since 2 of the 8 balls are green, a green ball can be selected in 2 of the possible outcomes. We can now simplify this fraction to be 1/4, or we can rewrite it as a decimal, 0.25. So the probability that the selected ball will be green is 1/4, or 0.25. Let's try another example. Here we are randomly selecting one number from the given set, and we want to determine the probability that the selected number will be either even or prime. So we'll call up the probability formula. The probability that the selected number will be either even or prime will be equal to the total number of outcomes where the selected number is either even or prime divided by the total number of possible outcomes. Beginning with the denominator, we want to know the total number of possible outcomes. Well, there are 7 numbers in the set, and it's equally possible to select any of these numbers. So there are 7 possible outcomes. Next, we'll tackle the numerator. How many of those 7 outcomes are either even or prime? Well, of the 7 numbers, these 4 are either even or prime. So there are 4 outcomes where the selected number is either even or prime. So the probability is 4/7 that the selected number is either even or prime. Now, I've already mentioned the importance of evaluating the denominator first when tackling probability questions that can be solved using the probability formula. Now let's examine a question that illustrates the utility of this strategy. Here we are randomly selecting 2 people from 5 people, and we want to determine the probability that Amir is selected. To solve this, we can apply our formula. So the probability that Amir is selected is equal to the number of outcomes where Amir is one of the selected people, divided by the total number of ways to select 2 people from 5 people. So let's begin with the denominator. In how many ways can we select 2 people from 5 people? Well, since the order in which we select the 2 people does not matter, this is a combination question. we can select 2 people from 5 people in 5 choose 2 ways. Now, in most cases, you will find that the denominator is easier to calculate than the numerator. So when you begin with the easier part of this question, 2 benefits arise. First, in calculating the denominator, we may gain some insight into how to calculate the numerator. Second, if we are unable to calculate the numerator, we may be able to use the information about the denominator to eliminate some answer choices. Here's how. Let's say that we don't know how to calculate the numerator in this question. At this point, we can still evaluate the denominator. Here, 5 choose 2 is equal to 10. So although we are unable to determine the numerator, we still know that our answer is some fraction with an unknown numerator and a denominator of 10. Since the denominator is 10, we know that the correct answer cannot be 0.15, 0.25, or 0.35. None of these can be the correct answer since there is no integer that, when divided by 10, will result in any of these decimals. So even though we cannot definitively answer the question, we are still able to eliminate 3 answer choices before we guess. Incidentally, the correct answer here is E, and in future lessons we will examine techniques for solving this question. For the time being, however, this example question is meant to illustrate the importance of calculating the denominator first. In this lesson, we examined a fundamental formula for determining the probability of an event. This formula is of tremendous value when dealing with scenarios that have countable outcomes. In this lesson, we'll examine the use of complements to help make probability calculations easier. So what is a complement? Well, we'll use the following example to introduce this concept. Say we have a box containing 5 red balls and 2 green balls. If we randomly select one ball, the probability that the ball is green is equal to 2/7. Now, what is the probability that the selected ball is not green? Well, 5 of the 7 balls are not green, so the probability is 5/7. Now, if selecting a green ball is an event, then the complement of that event is selecting a ball that isn't green. In general, if an event involves something occurring, then the complement of that event involves that thing not occurring. So if an event is defined as winning a race, then the complement is not winning the race. Now here's the important part. Notice what happens when we take the probability the ball is green and add it to the probability of its complement, the ball is not green. When we do this, we get a sum of 1. Now you don't need to remember the definition of the word complement. However, you should remember these results, which we can generalize as follows. The probability that an event happens plus the probability the event doesn't happen will always equal 1. Or we can rearrange this equation to conclude that the probability that an event happens will always equal 1 minus the probability the event doesn't happen. Now let's look at an example of how this rule works. In this question, we are told that the probability is 0.45 that a randomly selected mouse is male. We want to determine the probability that the mouse is female. Now note that selecting a female mouse is the complement of selecting a male mouse, so we can use the following rule. When we apply this rule, we see that the probability the mouse is female is equal to 1 minus the probability that the mouse is not female. Now the probability that the mouse is not female can be rewritten as the probability the mouse is male. Since the question tells us that the probability is 0.45 that the mouse is male, we can add this to our equation, and when we simplify this, we get 0.55. So the probability is 0.55 that the mouse is female. Now this was a straightforward application. Now let's examine a harder question. Here we are selecting one number from each of 3 sets, and we want to determine the probability that the product of the 3 numbers is even. Now this question is very hard to answer without the use of complements. The difficulty lies in determining the number of selections that have an even product. Here are some possible outcomes where the product of the three numbers is even. As you can see, there are many such outcomes, so counting all of them might be difficult. However, this question is much easier to solve when we consider the complement. Now, what is the complement of having a product that is even? The complement is having a product that is not even. In other words, having a product that is odd. Now, in how many different ways can we select three numbers such that the product of the three numbers is odd? Well, for this to happen, all three of our numbers must be odd. Since each set has only one odd number, there is only one selection where the product is odd. So given this, we're going to use complements to solve this question. So the probability that the product is even will be equal to 1 minus the probability that the product is not even. In other words, the probability that the product is odd. So we now need to determine the probability that the product is odd. To do this, we'll use the probability formula. Now we want to determine the number of outcomes where the product is odd and the total number of possible outcomes. As always, we'll begin with the denominator. To calculate the number of possible outcomes, we'll take the task of building outcomes and break it into stages. One stage is selecting a number from the first set, another stage a number from the second set, and another stage a number from the third set. We can accomplish the first stage in 2 ways, the second stage in 5 ways, and the third stage in 4 ways. When we apply the fundamental counting principle, we can see that there are 40 different outcomes. Now we'll tackle the numerator. Here we want to determine how many of the 40 outcomes are such that the product of the three numbers is odd. As we saw earlier, there is only one way to select 3 numbers and get an odd product. So the numerator here is 1. Now that we have determined that the probability is 1/40th that the product is odd, we can answer our original question, which asks us to find the probability that the product is even. Now that we know the probability the product is odd, we can add this information to our calculations to get 39/40ths. So 39/40ths is the probability that the product of the three numbers will be even. Now in this lesson, we learned the importance of complements. They can be useful if you find that calculating the probability that an event does not occur is easier than calculating the probability an event does occur. Also, in questions involving at least and at most, you may find it beneficial to consider the complement of an event.